Hello and welcome to this video where we'll go into Kafka producer and consumer using quixstreams. This will be super interesting to go hands-on into coding out what we've seen in theory. Make sure you have watched the setup so that you have the Docker Compose YAML file, because we will directly go into using Docker Compose. I'm in Visual Studio Code now, and you can see this is my Docker Compose YAML file. It's the same as the one in the setup lecture. So you can see there's the services, we have broker, schema registry, and control center. And then we remove the REST proxy, right? So now I have started my Docker desktop. Let's do Docker Compose -d to make it in detached mode. You can see it starting up very quickly because the images already exist, right? So let's do Docker PS. You can see my containers are up. We have the broker, control center, and schema registry, right? Let's clear my terminal and create a virtual environment because we're going to install packages. If you already have your virtual environment, your UV, then just do UV pip install. So after you have activated it, since I start from nothing, I started my virtual environment. So now I will do source.ven bin/activate, and as in Windows is scripts, right? So now I've activated my virtual environment, and let's do UV pip install quixstreams. Yes, this is basically what I need for this lecture. I will create some folders, make dir data, make dir src for source. I will move some data into my data folder. I will provide link in the video so that you can see the data as well. You get the link to the repository so you can download the data and follow along. Here, it's basically some jokes that I've gotten from ChatGPT about data engineers. Some of them might be creative, some of them I think are not very good actually. But for example here, why did the data engineer break up with the database? Too many relationships. Yeah, that was funny. I will do touch src/producer.py, and then I will do a consumer.py as well. Okay. So now let's do code source producer. So this is the producer file. And here we'll do from quixstreams. You have seen me going into quixstreams before, but I will just give a reference again. Quixstreams docs. So this is the quixstreams, and we can see here in the quick start, I have taken most of the code from here, or at least a lot of inspiration from here, so I won't take credit. Instead, you can go into the documentation. I think it's quite good documentation, and learn more about quixstreams. There's quick starts and several tutorials that you can go through. Let's close this down now and go back to Visual Studio Code, and I'll show you. So quixstreams import application. Then you create something called an app. App is application, and then you choose the broker address, right? Okay. So note that the broker is the server, right? And the address, it's basically which port or which URL, if you have if it's publicly available or not. For us, it's a local host. Remember that it's localhost 1992, right? So this is the broker address. We remember that in our Docker Compose YAML, right? So broker address is 1992. So this is where we will be able to create our topics and publish the events there and subscribe from the topics, read from the events there, right? So this is quite cool. And then we'll have consumer group. What will the consumer group be? A consumer group is a group of consumers that work together to consume messages from a topic in a coordinated manner. We have several consumers to consume from a specific topic, right? So that is the consumer group. So consumer group equals text splitter. I'll call it text splitter. In the quick start, you'll see text splitter v1, but it doesn't matter. I will call it text splitter as long as we will use the same. Some of the things are from the quick start, but I have made some other changes. So we're starting with an app. When going into a new system, I will learn a little bit about the app. I'll increase the size a little bit. We'll learn a little bit about what we have here. Just run this one. And you can see, yes, it's a quixstreams.app.application object at a memory address. This is the default wrapper of this object, this instance. So it's basically an app.application object. That doesn't say so much, but let's move on here. As we will create a topic. So jokes, topic, I will call it jokes. They used messages in documentation, but let's do some jokes here because we have some jokes data. So app.topic. So now we'll create a topic. So name of our topic is jokes. And then we will have also a serializer. So this is quite interesting. So what is a serializer? It lets me serialize the message. So basically my message is starting with a string, right? And I need to serialize it in a special way in order to send it, right? If I want to serialize an object, I will serialize in a special way. In this case, it's in the JSON format so that we can send it into the topic. And when you're sending messages, you need to serialize and deserialize so that you get back the original message, right? We choose JSON because we have JSON data. And then we have jokes. Okay, so now I will print jokes topics and see what that is. This is how I try to understand what I'm doing. We can see here they have done the string or done the wrapper. It's the topic name jokes. That is interesting. Okay. The help, you can see class topic, and it's basically some definition of a Kafka topic. Typically created with an app equals quixstreams.app.application instance via app.topic. So we have created an application instance, and from the application instance, we have used app.topic. So we have created a topic, right? And this topic, you can see if we wrote it out, it says the name of the topic. So if I run this one, topic name jokes. Okay, great. Now I will just read in the data. So from pathlib import path, and then import JSON because we have JSON data, right? So let's read in the data. We'll have jokes. Jokes path equals to path dunder while and dot parent, because dot parent will go into source, dot parents of 1. Because dot parents of 0 will go into source, dot parents of 1 will go into Kafka consumer producer. And in this one, I will go down into data and down into jokes.json, like this. Okay, now I have a jokes path, open, jokes, comma, R for reading, and then we'll have an encoding of UTF-8 as file. Okay, and then we'll do jokes equals to JSON.load file, basically. So I'm just reading in the data, so there's nothing fancy here. So let's print out so that we can see the data. So jokes is the data that you read in. Jokes. Run this one, and you can see here are the jokes. Cool. And it might be hard to read, so we could actually do from pprint import pprint. This is pretty print. So if I do pprint of jokes, we can see, yeah, it's much better to read it in this way. So now you have, there's a joke ID and there's a joke text, right? So joke ID, joke text, joke ID, joke text. These are the keys, and you see the values are basically, ID is an integer and this is a string for the joke text. Okay, and now let's create our producer. So def main, this one I follow from the quick start with app.producer. get producer as producer. Let's print this one, print the producer. I will do this to comment, and then I will do the preamble if dunder name equals to dunder main and run main. So this is basically just if I'm running this one, then this main function will run. Otherwise, if I'm importing it, it won't run. Yes, let's run this one. Here up the terminal and run it. Okay, interesting. What happens here? We have topics required for this application, jokes. Creating a new topic, jokes, with config number partitions equals 1, replication factor 1. Topic jokes has been created. Validating Kafka topics exists and configured correctly. Kafka topics validation complete. But basically the producer, when you do app.get producer, it will look into the topics that it doesn't have. So it creates this topic. So now we have a jokes that has been created. So let's go into the broker and check that this topic has been created, but let's do that later on. I clear my terminal. And the controls, I will comment out this one. So let's do like this. Kafka message equals to jokes topic. So this is the jokes topic, right? So we created this topic. And from this topic, we do serialization. And what do we want to serialize? We want to serialize on the key equals to joke. We need to actually look through this, sorry, for joke in jokes. So then we're going through each of the jokes. And in each of the jokes, we serialize the joke. And what do we serialize? We serialize the joke ID first. For the key and for the value, we serialize joke of what it's called. It was joke value equals to joke. I printed out the jokes. And you can see for each joke, it's this dictionary here. And we can see that the key is basically the joke ID. So you can see the key here. And the value, we pick the whole joke here with the ID as well. Note that we need to send the whole object and not only the text, right? Because we want to have the joke ID sent as an event as well, because it will be easier to trace it later on. So this is how it looks like. We have the Kafka message. And then let's print this. Print an F string here, reduce event with key. And then we'll just put in the key, so Kafka message.key, and we'll do value equals to Kafka message.value, like this. So now I'm just printing, right? And I'll remove the printing of the producer to clean up this file a little bit. So now we haven't produced anything. We're just printing. So I will clean this out and I will run this one. Okay, so what am I printing? You can see here, produce event with key equals 1. Because this is Kafka message.key. And then the value is this serialization. So I have made this serialization. Basically, it means I have from this JSON object, I made it into a string. I made this into a string, the whole object, with the joke ID and the joke text. So with the joke ID and the joke text, the whole object becomes a string. Much easier to send a string than to send an object. So let's move on to actually producing this message. So producer dot produce topic equals to jokes topic. E equals to Kafka message dot E. And the value equals to Kafka message dot value. Just like this. And I'm done. Hopefully, I run this one. Yeah, I hope, but not. There's an error. Type error, argument 1 must be string, not topic. Argument 1. Okay, let's see. What is the argument 1? The joke ID here. This one, this key, can I just do like this? String of the key, right? Because this was number. So if I run this one now, yes, it works. No, it doesn't work. Argument 1 must be string, not topic. Let's see. Argument 1 must be string, not topic. Oh, okay. What could I do? The joke ID. Yes. Argument 1, right. Jokes topic dot name. Because it must be the string. So jokes topic where the whole object, right? It's a topic object, and we do dot name to get the actual string, the jokes. Okay, let's run this one. And yes, there's another error, and it says bytes like object is required, not in. Okay, so then not int on the key probably. So let's make this one into string. Okay, how about now? Yes, it works. Cool. That was super cool. Okay, we have produced a lot of messages. So let's go and check what we have produced. Let's go into Kafka. So Docker PS, we have a broker, right? So let's go into broker. Docker exec -it broker /bin/bash. Okay, now I'm inside of the broker, and inside of the broker, I can do the commands that I did in the last lecture, right? So what can I do? I can do it like this. Kafka topic dash list, and I need to choose which server do I have. I have localhost 1992, right? Cool. So these are all the topics that exist here. However, we have the jokes topic, and this is super cool. Okay, so this was the topic that we created. It really works. So cool. Okay, so let's go into actually describing this topic. So Kafka-topics-describe-top topic name is jokes, right? And bootstrap server localhost 1992:1992. Yes, this is the description of the topic that we created. So the topic, jokes, it has partition 0, leader 1, replicas. We see that it works. Okay, so now to read the data inside this topic, Kafka console consumer bootstrap-server localhost 1992 -- topic. Which topic do I have? I have jokes, and I want to read it from -beginning. We can read it. You can see, yes, we have joke IDs here, 1 to 10, and the joke text for each one of them. We have read it. And this is one way to read it. Another way is to actually go into our browser. And let's see where we had the control center. We have localhost. Let's see. What is our control center? We do Docker, we do Control C and Control D to exit this one, and Docker PS. And we can see the control center is here. Control center is 9021. Yes, 9021. Localhost 9021. Okay, a control center, one healthy cluster, topics 52. And we can see jokes. This is the topics that we created, right? And inside this one, we have schemas. Actually, we haven't put the schema yet, but messages. Yeah, why? How come? Because it has already read those messages, right? We read the messages before. So let's try to create messages to go back to our producer app. So let's do Python producer. Let's say Python src/producer.py. Okay, so now I run this one. When I run this one, there's 10 new messages, right, inside of our topics. You can see there are 10 messages now. And here you can see each of them. And you could download it and to view it. But basically here, let's see this one. What's a data engineer's favorite type of music? Heavy metadata. Now we have consumed using the control center, which is the UI. We have consumed using the CLI in the broker. But let's use quixstreams to actively consume these messages, because when we're consuming these messages, we might want to do some further processing, right? So let's move on to quixstreams, go back to Visual Studio Code. Okay, so now we have come down to creating the consumer, going into the consumer here. As you saw before, we used both the broker and the control center to see the data that we have published to the topic. Now it's time for us to programmatically consume it and do some processing. From quixstreams, import application. Note that application, this is our starting point. So even in the consumer app is application. We create an instance from the application. So broker address equals to localhost 2. And then we have consumer group. It's the same consumer group as before. So it's the text splitter like this. And then we have auto offset reset. This means that we want to read it from the earliest and not just read from whenever new data is coming in. So here you can choose from latest or earliest or error, right? So I'll pick from earliest. And now we'll have jokes topic. So here app.topic, and we have name equals to jokes. Note that we have serialized the data. We printed it out and saw the serialized format. When you're reading it now or subscribing to it and consuming the data, you need to deserialize it to get back the object, right? So we deserialize with the JSON. And then this is quite interesting in using Quix and quixstreams. There's something called streaming data frame. So SDF equals to app data frame. So if you've worked with pandas before, this will feel a little bit familiar, but not exactly. However, in pandas, there's some apply method which you can use, and there's also map method. And for streaming data frame, these are used quite frequently. So let's create a data frame first, and the data frame you create from a topic, and basically it's the jokes topic. This will give you API similar, so a data frame API that will be very helpful. So this is streaming data frame. If done the name equals to done the main, then I will do app.run basically. I will also print out from my data frame. So my streaming data frame equals to streaming data frame. Update this method can perform a side effect. And in this case, I want to just print out the message. So print f-string inputs like this, and then I will put in the message. The lambda is basically just a function, an anonymous function. It returns the message. And it's having the message as input. The function will itself just run this print message, this f-string. So when it runs, you will see input data and print it out. So basically the one that we consume. Hopefully, let's run this. So Python, or let's run this one. And when running it, that there's a lot of input now. And the input is basically, as I ran this twice, input 1 to 10 and then 1 to 10 again, right? This is the f-string, right? It's the input. and then the whole message for each of the row. It read all the events or all the messages in the topic and printed it out. Cool. If I run this again, I will remove this one. I run this again, and you can see nothing will come now. That's because I've already consumed the data. In Kafka, they have an offset that they will keep track of which events that you already consumed. Since I've consumed this, they won't be consumed again. If I go into my other terminal, and I will do like this, ls python source producer. If I run this one, you can see that it produced these events, right? 1 to 10. And if I go back to my other terminal where I ran my consumer, you can see, voila, and it has consumed more messages. So because this app is still running, it consumes whenever we have more messages in the topic. We have published more messages to the topic. This will read it in real time. So we have read the messages in real time and printed it out, basically. So this I would call, it's a streaming application, real-time streaming application. So let me close this down and continue with this consumer here. I'll continue with the example from the quick start example. What they have is SDF equals to SDF. So apply means that you will put in a function here and it will run this function on each of the messages. So then I'll do lambda message. And what will I do here? I will do a list comprehension of word, word, for word in message. In my message, there's a joke text, right? To get the text. Message of joke text dot split. So basically what I do here is that I split the words. So I split the message into words. And then I will apply this so that I will get word what word it is. For example, I will get y, did, the, data, engineer, and then break, etc. It means that, okay, I'm splitting this text into words. Okay, let's do that. So if I run this one, consumer, you can see nothing happens because I'm waiting for data. So I go back here and then I will run the producer. Now it has produced a lot of things, but it didn't do anything because I didn't print it out. So let me copy this one and print out. What do I want to print out? I want to print out lambda row, and this is the output. So I've done some processing, I've done some transformation to the data. Note that we have extracted, we have transformed the data, and now we get an output, right? So let me stop this one and run this again. And we can see nothing happens because we don't have data. So we'll produce some more data. We go back here and we can see what happened. Exactly what I said, word grandma, word she, etc. This is not very helpful, right? It's hard to read. Why do I do that? We will actually do some other thing. We will do comma expand equals to true. So this is to expand this. And I will close this down and run it again. Nothing happens. We wait for more data. So I run this one, run the producer, go back. And now when I expanded it, it gets more interesting. So we get from the input, this one. Why did data engineers get a therapist? It had too many fact and dimension conflicts. Oh, this is very funny when you're working with a data warehouse where you have facts and dimensions in star schemas. Or you have data snowflake schemas, which is quite hard to grasp. But no matter the joke, the thing is that the output is each word, right? So I have the word, but now I also want the length of the word. So let's do that. So length. So this is similar to in Pandas. So you create a new column with the length. So create a new columns with word lengths. So this is sdf.apply. And apply, we do lambda message. And then we apply the word now, right? Because each word is our input now. So the word is basically a length of word. Like this. Does this make sense? So now let's do this. So why does it make sense? We expanded it so we get a word for each of them. We get only these words, and then we do the length of the words. Okay, so let's stop this one and run it again and go back here to produce some data, and we can see how it works now. Length 1. Yeah, that's why I thought it was a little bit weird when I thought about it. It didn't make sense because here I use the whole data frame, and then basically I get a dictionary, but I want to have the dictionary, the word. I want to get the value. So then the length won't be 1, then the length is of a string. Let's stop this one and run it again, and then go back here and run this one and go back here. Now it makes sense and it's correct. So word music and question mark 6 of 2, etc. We did some processing and added it to our streaming data frame. Okay, this was quite cool. In this video, we have learned how to programmatically create a producer to produce data to a topic. We have consumed the data using both the container, the broker, the CLI, using Kafka-consumer, that Kafka-topics-consumer, I think. Yes. No, we've used the Kafka console consumer in the CLI side of the broker. We have gone into control center to consume the data, and we have finally gone into programmatically consume the data from Python using the quixstreams library. And then when we have done it programmatically, we have also done some transformations, such as we have splitted the words and we have computed the length of each of the word in each joke text. This is quite cool and is quite simple application, but it's good for you to start with. Thank you for watching this video and see you in the next one. Bye.